In the summer skies of World War II, few aircraft inspired as much awe or fear as the Lockheed P-38 Lightning. With its unmistakable twin boom, central nacelle, and turbocharged engines, it looked like nothing else in the air. American pilots loved it. German and Japanese pilots dreaded it. But behind its success lay a story that almost no one outside the aviation world has ever heard. A story not generals or engineers or test pilots, but a civilian. A single man whose impossible idea would make the Lightning almost untouchable. This man wasn't a soldier. He wasn't even a trained engineer. In fact, the experts laughed at his proposal. What he suggested went against everything known about aircraft performance at the time. Yet when his idea was finally tested, it changed the way America's P-38s fought and survived the brutal air battles of the Second World War. To understand what made his idea so groundbreaking, we first need to step back into the late 1930s, a time when the United States Army Air Corps was racing to catch up with the rapidly advancing world of aerial warfare. The skies over Europe were already echoing with the engines of German Messerschmitts and British Spitfires, sleek, fast, deadly machines built with one purpose: dominance. But across the Atlantic, the U.S. was still experimenting. Lockheed Aircraft Company, then a relatively small outfit, was given an ambitious challenge by the military: build a fighter that could fly faster, higher, and farther than anything on Earth. It needed to climb at more than a mile per minute, reach speeds over 400 miles per hour, and be able to engage the enemy long before the bombers even reached their targets. The result was unlike any fighter ever designed: the P-38 Lightning. Its twin Allison engine sat in long, slender booms, while the pilot and armament were contained in a central pod. It looked almost alien, a futuristic weapon from another world. And when it flew, it shattered expectations. The P-38 was fast, very fast. It could dive at tremendous speeds and climb like a rocket. Its twin-engine layout meant that if one engine was hit, the other could still bring the pilot home, a luxury that single-engine fighters didn't have. With 4.50 caliber machine guns and a 20mm cannon mounted in the nose, all firing straight ahead, it could rip through enemy aircraft without worrying about convergence angles. But there was a problem, a deadly one. At high speeds, especially in dives, the P-38 became dangerously unstable. Pilots reported the controls stiffening until they could barely move them. Some aircraft entered uncontrollable dives, plunging into ground or ocean before the pilot could pull out. Dozens of pilots were killed trying to figure out what went wrong. The issue was traced to something called compressibility. As the Lightning approached transonic speeds, around 500 miles per hour, the airflow around its wings began to behave unpredictably. Shock waves formed, the center of pressure shifted, and the tail lost effectiveness. In short, the faster the plane went, the less control the pilot had. And once the nose started to drop, nothing could stop it. Lockheed's engineers were baffled. They designed the plane using the best wind tunnel data available, but the data itself was incomplete. No one had fully understood the behavior of air at near supersonic speeds. The United States was still years away from breaking the sound barrier. This was uncharted territory. By 1942, the P-38 was fighting in nearly every major theater of the war, from the frozen skies over Europe to the humid, treacherous jungles of the Pacific. It was America's only long-range fighter capable of escorting bombers deep into enemy territory. But that same dive problem continued to haunt it. In the Pacific, where Japanese Zeros could turn tighter and climb faster, American pilots learned to use the P-38's speed and firepower to their advantage. Boom and zoom tactics, high-speed dives followed by quick climbs, became standard. But those dives carried risk. Too steep, too fast, and the Lightning could become a death trap. It was during this time, as test pilots wrestled with the aircraft's terrifying tendency to lock up mid-dive, that a civilian named Clarence Kelly Johnson began searching for a solution. Johnson, Lockheed's brilliant but unorthodox engineer, was already a rising star in aviation. But even he was running out of ideas. Every fix they tried failed. Every adjustment to the tail or wings either worsened performance or did nothing at all. Then came the impossible trick. It didn't come from Johnson himself or any of his elite engineers. It came from an unlikely source, a civilian technical specialist who wasn't even part of the design team. His idea was so unconventional, so absurd to the aerodynamic minds of time, that it was nearly rejected without testing. But something about his explanation caught Johnson's attention. It was simple, maybe too simple. And yet, as history would show, this simple idea would transform the P-38 from a dangerous enigma into one of the most feared aircraft in the war. It would allow pilots to dive faster, attack harder, and escape enemy fighters with impunity. Before the idea, P-38 pilots fought their own aircraft as much as they fought the enemy. After it, they ruled the skies. By late 1943, the Lightning had become a legend. It escorted bombers over Europe, struck deep into Japan's empire, and claimed the lives of hundreds of enemy aces. In the hands of American pilots like Richard Bong and Thomas Maguire, it achieved kill counts unmatched by any other fighter type. But few of those pilots ever knew that the reason they survived, those moments when they pulled out a screaming dive at the last possible second, was because of a modification dreamed up by a man who, by all accounts, had no business telling Lockheed's engineers what to do. What exactly was this impossible trick? How could one simple change solve a problem that the world's best engineers couldn't crack? And why did it take a civilian outsider to see what everyone else missed? The answers lie in a story of intuition, courage, and an almost reckless willingness to defy the rules of aerodynamics. A story that begins not in a lab or an airfield, but with a curious mind that refused to accept that impossible was truly impossible. And as we'll soon discover, that mind's idea didn't just save airplanes. It saved lives.